This is lesson 4.1, multiplication patterns. It is found on pages 165 through 168 in your workbook. So I got to get something off my chest here and let you know something. Perforated paper. Perforated paper is just terrible. Oh, good gravy. Moving along. So our learning target for this lesson, we're going to find products involving multiples of tens, hundreds, or thousands. And of course, if you don't understand it yet, that's okay. That's why you're in school, right? But hopefully at the end of the lesson, you'll be a 3. And if you're a 4, you can help those who need help. All right. So let's look back and complete the tables. Well, 8 times 10, we've got 80. Ready? 8 times 100 is 800. Will we be multiplying 8 by to get 1,000? Yes, 1,000. Here are my 8s again. And then 8 times 10,000. Right? And then we can do 23 times 10, which would be 230. And then 23 times 100. And then 23 times 1,000 would be 23,000. And then 230,000 would be 23 times 10,000. All right, well, in our look ahead, it says, what patterns do you notice in each table? And here's what I'm going to say. The number of zeros in the product is equal to the number of zeros in the factor. So if we look back here, if we're looking at this, 1 0 here, 1 0 here, 2 zeros here, 2 zeros here, 3 zeros here, 3 zeros here, 4 zeros here, 4 zeros here. Now, you know what? If it was 80 times 10, it would be 2 zeros as well. See? 1 0, 2 zeros, 2 zeros. All right, so, like I said, the number of zeros in the product is equal to the number of zeros in the factors. And they want us to explain how to find the product of any number and a multiple of 10. Here's what I'm going to say, and it's a little different than what they say, but here's what I'm going to say. Multiply the non-zero factors and add the total number of zeros to the product. And here's the example that was on the other page. If I took 80 times 10, I would do 8 times 1, which is 8, and then add the total number of zeros to the product. That's how I would do it. They're going to say it a little different way and show it in a little different way in their key concept, in our key concept, but it's the same thing. It's the same thing. We're doing the same thing, just saying it differently. All right, so let's look at our key concept, use patterns to find products. All right, in our example, find the product of 46 times 1,000. We do 46 times 1,000 equals 46 thousandths. That equals 46,000. So 46 times 1,000 is 46,000. And then our pup over here says, remember, every time you multiply a number by 10, the number shifts one position to the left in a place value chart. The number shifts one position to the left. So every one of these zeros makes that 46, not 40. Makes this 46 go one position to the left. So instead of 46, it's 460, 4,600, 46,000. So it pushes it one position to the left for every one of these zeros. All right, so in our next example, it says find the product of 40 times 600. See how it uses the associative property here? And it gives 4 times 6. So I said, remember, doing the non-zero digits, 4 times 6 is 24. 24 times 1,000, because 10 times 100 is 1,000. 24,000. So 40 times 600 is 24,000. And we're using the associative and commutative properties, right? Because remember, the associative property means you can put parentheses and it doesn't change the value, and the commutative property means you can move things around and it doesn't change the value. All right, and our cat here, you can use the symbols X or dot there to indicate multiplication. For example, the product of 40 and 600 can be shown as 40 times 600 or 40 times 600. So both of those, and we've seen this in our reviews, both of those indicate multiplication. So with that understanding, let's do some in-class practice. All right, I am going to do number 1 with you, and I want you to do number 2 on your own. All right, so 78 times 1, we've got 78, and 1, 2, 3, 4. 1, 2, 3, 4. All right, go ahead, complete number 2, and then we'll go over it. So 2 times 4 is 8. 1, 2, 3 zeros. 1, 2, 3 zeros. See, we multiply the non-zero digits and then add the zeros. All right, I'm going to solve number 3, and you can solve number 4 and 5. All right, so 1 times 11 is 11 with 1, 2, 3 zeros. 1, 2, 3 zeros. All right, go ahead and do number 4 and 5, and then we'll go over it. 4 times 7 is 28. 1, 2 zeros. 1, 2 zeros. 3 times 9 is 27 with 1, 2, 3 zeros. 1, 2, 3 zeros. All right. You do number 6, and then I'm going to show you number 7. All right, so 1 times 6 is 6. With 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5 zeros. Let me put that underneath here to make it look better. All right, so number 7 is kind of tricky because you were told, hey, take the non-zero digits and multiply them. It's really the non-zero digits that are not part of the number itself. What I mean by that is that we're not going to take this 0 out. We're not going to say 26 times 1. Okay? We're not going to do that. We're going to do 206. 206 is the number. Right? If it was 260, we could just do 26. But it's not 260, it's 206. So we're going to take 206 and multiply it by 1. Multiply it by 1 and then add those 2 zeros. So when the 0 is basically inside of a number, when it's part of the number itself, we don't take that 0 out. We use that as the number. All right, you go ahead and solve number 8 and we'll go over it. 15 times 2 is 30 with 2 zeros. Did you notice what happened there? Yeah, we've got 3 zeros at the end because 15 times 2 is 30, and then we add the 2 zeros. Yeah, we don't just add 1 0 and think, well, we have the 2 zeros there. No, you add 2 zeros to whatever the product is of those 2 non-zero digits. And the product of those 2 non-zero digits is 30. So then you add the 2 zeros. All right, I'm going to show you number 9, and then I want you to do number 10 and 11. All right, so something times 3 is 15. 5 times 3 is 15. Well, this has got 3 zeros in it, right? Well, we've got 2 zeros here, so we need 1 0 here. So 50 times 300 is 15,000 because 5 times 3 is 15, and then I add those 3 zeros. All right, you go ahead and solve 10 and 11, and then we'll go over it. All right, it's already got the 2 zeros there. It's already got 2 zeros there, so I'm just going to multiply it by 54. 54 times 1. I know that, let's see if you got this. I know that 5 times 8 is 40. 5 times 8 is 40, and I'm adding 3 zeros. Yes, because 8 times 5 is 40. There's our non-zero digits, the product of the non-zero digits, and then we're adding the 3 zeros. Oh, would you get that? All right, moving along. What do you know about the digits in the product of any whole number and 100? And here's what I'm going to say. It will have at least 2 zeros at the end, right? Because if I'm multiplying it by 2, it's going to be 200, have 2 zeros at the end. But if I multiply it by 20, well, it's going to have more than 2 zeros at the end. It's going to have 3. But, you know, because 20 or 2 times 1, and we add those 3 zeros. So because it's times 20, I'm going to have that extra 0, but it's going to have at least 2 zeros at the end. All right, I want you to go ahead and solve number 13 on your own. Read it, solve it, then we'll go over it. All right, select all the expressions that are equal to 24,000. Well, that's 24 with 3 zeros. There we go. 3 times 8 is 24 with 1, 2, 3 zeros. 4 times 6 is 24 with 1, 2, 3, 4 zeros. Not that one. 24 times 1 is 24 with 1, 2, 3 zeros. So everything except C was correct on that one. Alrighty. Number 14 is a lot easier than you think, right? It's because it says complete the pattern where those 2 hearts are digits. Well, all I need to do, we've got 10 times these digits, so these digits, 1 0, right? Because I got 1 0 in the 10. How many zeros are going to be in this one? That's right, 2 zeros. How many zeros are going to be in this third one? 3 digits. 3 digits, 3 zeros. Well, the digit is 0, but specifically 3 zeros. All right, so remember the pattern. You add a 0 to the end depending upon how many zeros there are in that power of 10. Alrighty, I want you to go ahead and solve number 15, and then we'll go over it. Alright, so 1 0 to the end of 362 would be right here. Alright, this 36 will have 2 zeros added to the end. There we go. This 36 will have 3 zeros added to the end. Here we are. And this 362 will have 2 zeros added to the end. There we are. Number 16 is a cool puzzle. It says solve the puzzle. So what I want you to do is figure out this puzzle. Figure out this puzzle. We haven't done powers of 10, so I'm going to show you what that's going to be real quick. It is 1 with 1, 2, 3, 4, 5 zeros. So it's 100,000. All right, but what I want you to do, I want you to solve this puzzle. If you get the correct answer, you know what you get, don't you? A Jolly Rancher. So go ahead and do that, and then we'll go over it. I'll come around and check it, make sure you've got it, and then we'll go over it. All right, so I know that 10 times 10 is 100, so the football is 100. Well, we've got 3 zeros here. That's 1 0, so I need something with 2 zeros. There we go, right? And then this is 100. Well, that's 2 zeros, and I need 5, so 1, 2, 3 zeros. So now I've got 10. The tennis ball is 100. The soccer ball is 1,000. 1,000, not 100. And then I've got 1, because it's 1 times 1 times 1, and then 1, 2, 3, 4, 5, 6 zeros. 1, 2, 3, 4, 5, 6 zeros. 1 million. Hope you got that. Alright, so let's connect this to real life. So the test prep says a black bear consumes 12,000 calories each day for 30 days. A grizzly bear consumes 400,000 calories in 30 days. Select all the statements that are true. Okay, so each day he does that for 30 days. So 33 times 12 is 36. 1, 2, 3, 4. 1, 2, 3, 4. So 360,000 black bear consumes in 30 days, and the grizzly bear consumes 400,000. Okay, so the black bear consumes more calories in 30 days than the grizzly bear? No. The grizzly bear consumes more calories in 30 days than the black bear? Yes. The grizzly bear consumes the same number of calories in 30 days as the black bear? No. Nope. Altogether, the grizzly bear and black bear consume more than 1 million calories in a day? No, because that'll be 760,000. And then the grizzly bear consumes 40,000 more calories in 30 days than the black bear. So, yeah, 40,000 plus 360,000 would be 400,000. So it's those two. All right, so paying close attention to what it gives you. Paying close attention to what it gives you. Go ahead and solve number 17. All right, your heart beats 120,000 times each day. In 1 week, a professional athlete's heart beats 607,000 times due to increased blood flow from training. How many more times does your heart beat in 1 week than the athlete's heart? Well, if you're just looking at this and not paying attention, it looks like that his heart beats a lot more than your heart. But that's 1 day. And it wants 1 week. 12 times 7 is 84. Add those 4 zeros. All right, and that's 607,000. So we're going to subtract those numbers. 10 times 7, 10 minus 7 is 3. 3 minus 0 is 3. 8 minus 6 is 2. So 233,000. 233,000 times more in a week than a professional athlete's heart. Yeah, they're in really good shape. All right, I want you to go ahead and solve 18 and 19. Solve 18 and 19, and then we'll go over it. All right, a whale's brain weighs 1,000 times as much as a platypus's brain. The whale's brain weighs 9,000 grams. How many grams does a platypus brain weigh? Oh my goodness. You know what? This is division. We're doing multiplication. Why they all of a sudden they say division? Yeah, it'd be 9 grams. Why is that, Mr. Pangburn? Well, look. 9 times 1,000 is 9,000. So 9,000 divided by 1,000 would be 9. All right, a pig's brain weighs 20 times as much as a platypus's brain. How many grams does a pig's brain weigh? So 20 times 9. 2 times 9 is 18. With 1 0, 180. Hope you were paying attention to that. Alrighty, let's go over our learning target again. Find products involving multiples of 10s, 100s, or 1,000s. Hopefully you can do that on your own. I can explain how to find a product involving multiples of 10. Again, on your own. I can explain how to multiply a number by 10s, 100s, or 1,000s. Alright, hopefully you can do this. And if you can teach someone, that's great, because you can help those peeps who still need help. And of course, I love you, so I will help you as well if you need it. Just need to ask. All right, have a good one.